It's not counting.
Är det i VM man gör det? Ja. Vi kan göra det. Ja, just det. Ja, det gör man på det. Jag frågar dig om jag blev. Men efter då. Halva veckan var försökt förstå varför det funkade. Men det är ju ofta så. Det är skitsatt sätt. Men det var det vi sa också, vi lärde oss inte hur mycket som helst, men inte det vi skulle lära. Men det, alltså, det är jätteofta det så. Det är också egentligen sånt som inte. Det är lite så här kommandofönster som ska sitta och skriva där. Det är lite för... Det ser halt ut. Ja, men du ska grön text också. Då har du grön text på svart. Det är som Matrix. Jag skulle bara låtsas det är en massa siffror och sen ser du bara bredvid. Har du inte, det finns ett tema typ. Den är så här radbrytning med massa H i. Men du vet inte, det betyder inget. Men det ser bara coolt ut. Så jag sitter och skriver, det är så massa H som kommer där. Ja, det är massa radbrytning. Om det kommer rundbrytning. Ja. Sen bara kommer den längst ner bak. Det är den. Du har creatat den här mappen. Så jävla hardcore. Hur går det med ditt egna projekt då? Jag får en mycket med programmeringsfysiken. Det är också ut på det. Känns som det är svårt. Det är som här. Och så på lite minimum färdigt som de här.
I guess it's streaming, right?
De flesta får. Jag skickar in. Kontrollera in.
So is it streaming on the YouTube? Okay, so it's on, yeah. So let's start. So, good morning everyone, and welcome to the second lecture of Requirements Engineering. I hope everyone can listen to me remotely. So, after the first lecture, someone was asking what is the reading list or what we should read for this part of the course, and I replied like, you don't need to read any external materials. if you just follow the slides or use the slides for your assignment, it should be more than enough. And that's why I have rich contents in the slides, and hopefully it will be not a problem for the assignments as well. So today we will talk about requirements validation and management. And in the first lecture we talked about requirements engineering, requirements analysis, and some aspect of analysis method, like how we can assign risk, how we can assign priorities, and in general how we can analyze requirements. And we also defined or showed some checklist. And we will do the similar thing today. So we will basically look at some checklist, like how we can validate requirements using a more systematic approach, and also how we can manage the requirements once they are documented and defined. So there will be two parts for this lecture. One is the requirements validation, and another one is requirements management. And I will try to go a little bit faster because last time it was a little bit longer than expected, and maybe there was too much content also. So what is requirements validation? So requirements validation is basically nothing about, again, finding problems in the requirements and finding those problems or the problems that still exist at the requirement validation phase. Those can be either ignored or omitted from the initial requirements analysis phases. And some common problems, and usually again similar to requirements analysis, requirements validation also should be done by different stakeholders. But in this case, as you can see, requirements engineers and system designers both are also involved. So they have crucial involvement in this step, because now requirements are complete or more complete in a sense, and they are more correct than the analysis phase or initial analysis phase. So these are the more common problems that we can deal during the requirements validation phase, like if they conform to the quality standards, if they are still ambiguous, or are there still any conflicts that exist after the requirements analysis phase. And all these problems must not be exist after the requirements validation phase, because after the requirements validation we have the final requirements document, based on which the developer will actually develop or code the system. So if any of the problems are still there, that means you are developing a wrong product that will fail either during verification or during validation of the system itself. So the goal of the requirements analysis and also the requirement validation, as I mentioned, are both for finding problems or conflicts or missing information in the requirements. But the question is that what is the difference between requirements analysis and validation? So there is a very fine-grained difference between them, because requirements analysis, what it does, it deals with requirements that are more incomplete, that are in the natural language, that are not formally defined or presented using modeling notations yet. So it's easy to find problems during the requirements analysis, but it's also more ambiguous. So sometimes you might not be able to detect technical problems in the requirements, for example. But in the requirements validation phase, since you are already past that requirements analysis phase or requirements specification phase, now requirements are more incomplete. Basically, you try to remove, you already tried to remove the inconsistencies and incompleteness those in the requirements analysis phase. So now you are working with more complete requirements set or more stable definitions of requirements. And that's why requirements analysis or requirements validation is more difficult task, and it requires more expertise, like requirements engineers or system designers involved in the process. And there is a study, a research study, that shows once you have problem in the after the requirements validation itself, that means developers are developing wrong products or wrong system, and if you deliver that system to the customers, it's 100 times more expensive than if you detect problems early in the requirements analysis phase. And it's obvious because you already delivered the system, you deployed the system, and you have to bring the whole things back. So if you remember this figure from the previous lecture, so requirements validation are in the third or final phase of the requirements analysis, and before that you have requirements specification and requirements elicitation. So obviously the requirements analysis are in this part of the figure, but requirements validation that we are interested today are basically involve reviews of the requirements, prototyping, and feasibility studies. So all of these are basically part of requirements validation. And for example, after the business requirements specification, you are checking the feasibility of your requirements. That means you are trying to validate your business requirements. And then once you done some initial user requirements specification based on which you are doing some prototyping, that means you are trying to implement some requirements in a mock manner or draft manner. And once you have a detailed system requirements and specification, you are doing a formal reviews with all the stakeholders. So these are all kind of requirements validation, and based on which you will have a system requirements document or requirements document. But the requirements management basically comes after this phase. So the management of requirements begin after the final requirements document you have. But one of the first steps for requirements validation is to ensure that requirements document meet the standards. So you might follow IEEE standard or your own organizational standard, but once you have the requirements or requirements document, you have to ensure that that requirements document meets some standards, or they do not miss any important part or sections from the standard. And of course, the benefit of this is like you find the problems not only in terms of structure, but also in terms of any missing information, like from the requirements or describing the requirements. But who should perform this requirements check or standard check if the requirements are based on the standards? So it should be analyst or an engineer, not like third-party stakeholders or non-technical persons. So it should be analyst, and that analyst or that engineer should not be part of the requirements elicitation or specification, because if he already is part of the team that do the requirements elicitation or specification, that means he will not be able to find his own problems or mistakes. So if he is not involved in the specification process, and if he has the standard, because he is technical guy, so and then it will be easier for him to check the conformance with the standards. But how he can do that? Basically, he can simply highlight missing information or incomplete sections, and check for other common things like if all the diagrams or figures are labeled, or if there are any empty requirements, in a sense that those requirements are not detailed yet or not described well. So basically, he simply highlights and identify those problems in the document itself. So the problem is, once he identified the problems or deviation from the standards, what he will do? So he can do two things. The first one is he can return the whole document to the team, and if there is enough time, they can go through the whole document or rewrite the whole document, or simply he can take note of the deviations or mark those deviation points in the document and return it back to the reviewers. And this is feasible when you have short time or you want to save your cost, because creating a new document from the scratch is also very expensive and time consuming. And this option 2 is also feasible when there is tight deadline and the changes are minor, so you don't need to bother about those doing the whole thing again. But this option 2 should also be considered when there is no problem in the understandability of the requirements. So if the requirements are written well but not presented well, maybe you should follow the step 2. But if the requirements itself are not clearly explained, or there are critical problems in the requirements, there's obviously we should choose option 1 and redo the whole thing. Because again, the reason is that you cannot rely on wrong requirements or incorrect requirements. So after you check with the conformance with the standards, or if the requirements are stated following the standards. So also let me know if there is any questions in the Slack, because I am not following also Slack. And so after you finish with the checking with the standards, you also should formally inspect each requirements, not only from the documents perspective, but also from the requirements perspective. And this should be also done by a group of people. Again, those group of people should be different stakeholders, and they all obviously have different domain knowledge, different expertise, different skills. So this inspection team should be diverse, in a sense that everybody should bring their own ideas and own knowledge. And this is also a cost-effective way of discovering problems in the requirements, because if you have an inspection team that are discussing face-to-face, instead of sending back the whole document and redoing everything, it will basically quickly identify the problems and give you the solutions. So this is kind of formal meeting, and again, like checking in the document or standards, or if your requirements documents conform to the standards, this should be also be led or done by someone who was not involved in the requirements elicitation or specification phases, also because of the biasness issues. And how it is done is like one requirements engineer presents. I think I also discussed this in the previous lecture. Like one requirements engineer present each requirement to the audience, and they discuss and find the solutions to the problems in terms of requirements inspection. So what if we find some problems? And there are 4 general problems that can be found for each requirement. So first of one is the requirements clarification. So that means obviously it was not well clarified, or were not well stated, or in other words badly expressed. That is not technical, and that is not easily understandable. So the author, so here the author means the stakeholder who is proposing the requirement. So he must improve and try to rewrite the requirement so that there is no clarification issues. And then there is missing information. This is also obvious, like if your requirements seems incomplete, then you need to talk to your stakeholders and find those missing information and improve your requirements. And then also the requirements conflict. This is another problem. So if you have too many requirements, there obviously could be some conflicts between requirements, and you also should need to talk to stakeholders and negotiate if you want to remove one of them, or if you want to merge them, or how you want to proceed. And also the unrealistic requirements. So if it's not possible to implement, or not possible to test, or at least through this requirement, if you don't want to, or if you cannot imagine how it will work in a user interface way or other functional way, then it's obviously unrealistic, and you should talk to your stakeholders either to remove or modify it to make it more realistic. So for the reviewing requirements, as the team we are talking about, the inspection team, that should be a multidisciplinary team. So multidisciplinary team means their knowledge and skills and background should be diverse, so that they can bring their own perspective and view and discuss them, and so that also they can learn from each other. So that's another goal. And who can be in that team? So a system end user or end user representative, a customer or a customer of your system, one or more domain experts. So it can be even the user or the system developers itself. So he basically should know the domain that the system will be used. If it's a financial domain, obviously you should need financial experts, or if it's a legal domain, you should need legal experts, and so on. and one or more engineers who will be responsible for the design, implementation, and testing. And this development team is also core part of the review team of the requirements, and also some requirements engineers, because requirements engineers are basically responsible for delivering the final requirements document. So they should be involved in this team of requirements review. And as I mentioned, like their diverse skill, knowledge, and experience bring or make the discussion and also the requirements document more rich. And they also not only contribute, but they also learn from each other and develop their understanding of the other stakeholders' perspective. So requirements validation can be done also via a checklist. We also show a couple of checklists in our previous lecture for requirements analysis and also, for example, risk assessment. So there is another checklist for requirements validation, and what you do by it is basically you look for critical attributes that you need to focus more on. And also using this checklist, basically you ask for each requirements the same sets of questions to assess its validity, or if it's valid requirements or not. And the benefit of checklist is that it gives you a formal mechanism so that you assess each requirements thoroughly and effectively. And since managers or end users who are not always technical, they use this checklist as a checkpoint or as a scale of assessing their or validating their requirements. Because engineers or developers, they might be well aware of the validation checkpoints, but since management guys and end users are not so technical, they might need some help, and this checklist will basically help them. So these are the, I think, 7 questions that you should ask for each requirement. So basically, if you have 5 requirements, you will have this 35 questions for all those 5 requirements. And you make either tick or yes, no for each of the questions. And if you have yes for any of the questions, that means you have that problems with the requirement. The first question is, are the requirements complete? And also for assignment, I think you should have, or you will have this kind of task for the recurrence validation. For your sets of defined requirements, you will perform this kind of checklist validation or checklist-based validation. So the first question is, are the requirements complete? If there is missing information, so by looking at it, simply reading at it, or just looking at the requirements, you can say if it's complete or not. If your requirements is well defined or not. Is the requirements, or are the requirements consistent? So there should not be any conflicts or contradiction between requirements. This is also obvious. Requirements should be comprehensible. So if it's not comprehensible by a third person or second person that you wrote, that means your statement has a problem. It should not be also ambiguous. So number 3 and 4 are related. The document should be structured, so it should be again conform to some standards. So it can be either organizational standard or some international globally accepted standard. Are the requirements traceable? So you should also find relevant information for your requirements, like what are the related requirements, or who proposed these requirements, or why this requirements is important. So all this information should be also tagged with the requirements. And finally, as a whole, is the requirement document conform to the standards? So the requirements should be conform to the standards in both ways, as individual requirements and also as a whole, or as a requirements document itself. And if you find yes to all, no to all of them, or some yes or some no, depending on the questions, then if it's positive for all of them, then you can make sure that your requirements are valid. But these are not by testing. Because there is other aspect of requirements validation in terms of testing, but these are from the stakeholder's perspective or end user's perspective. So this is another way of, I think I have the, I had opened the lecture, so it was playing also in my machine. So this is another way of recurrence validation, and not only you have to confirm that or ensure that your requirements conform to the standards in terms of documents or in terms of individual requirements, and not only you should validate using that formally defined checklist, but you can also validate your requirements using prototyping. And prototyping is kind of experiments. Basically, you try to develop some kinds of mock requirements or mock interfaces through which you can test your functionalities. And prototyping is very common or known way of doing that. Indeed, or in fact, sometimes people don't want to do prototype because of time pressure, but this is a good exercise also for the end users as well as the developers. And this is also a very good way of discovering problems in the requirements, based on which feedback you can reflect those changes or problems in the actual development of the requirements. So this is one of the checkpoint for requirements problem, basically. Also, using the prototyping, you can write your test cases or system test, because without a visible element or without visible implementation of the requirements, sometimes it's hard to write test cases. So if you have a prototype, you can easily define the test cases. It can be used as a stopgap system, like if your delivery deadline is approaching and you are far behind your schedule, but if you have a prototype that is working and doing something for you at least, then you can use the system temporarily for the customers, and they can run their business based on the prototype system that you have already. And also, again, prototyping with the requirements, or if you want to develop a prototype, obviously you need to understand the requirements, right? So that is another checkpoint for the requirements, that if they are inconsistent or if they are incomplete, you can easily identify before you develop your prototype or during you develop your prototype, and it will be also useful for your final system as well. And as a last benefit of prototyping is that sometimes some systems, it's not for all systems, not critical systems, but for some systems you can extend your prototype or do some major modifications to your prototype and deliver this system as a final system to your end user. So you can simply modify your prototype and use it. So you are not losing your prototype. Basically, you are using your prototype, and you basically save your resource and money and time. So there are multiple approaches for prototypes, and one of the very cheapest, I would say, and also common is paper prototyping. And there is, of course, some benefits. Like as I mentioned, it's a very simple way of doing prototyping, but it might not give you the full picture of what's going on, but it can at least give you the idea what is the functional requirements or what is the user interface requirements, for example, for this system. So the goal or the method is that, like, you draw on pages or screens using pen and paper, or even on the screens, and you simulate the transition between screens or what you're expecting. And end users are always highly involved in this process. So basically, end users draw the screen what they want, and the engineers or the requirements analyst try to get some information and note down what users is doing, or what input or output, or how the users is interacting with the system. So it's a kind of simulation, basically with pen and paper, simulation with the system. So I will give you an example of paper prototyping here, and it's a famous project from BBC, so many years ago, and they wanted to make an experiment how paper prototyping, basically paper prototyping was introduced through this project. So they wanted to make a system that can play BBC radio. And they came up with these requirements saying that Joe, I think it's a girl, wants to listen to a radio program on a radio device rather than her laptop, and she finds the available devices, chooses one, and the radio program plays on the radio device. So she can do it basically in two ways. Either from her laptop she can connect to the device and stream from the laptop, or she can play directly on the device, like either using a verbal command or by activating the device itself. So how we can do that? So there are, as you can see, 8 paper prototyping. So in the first one, Joe simply draws her laptop and the device, or maybe the interface of the laptop, how it looks like. So once she go to the interface, she find that there are multiple options to play the device, and she selected only one, that is she wants to play this radio on a device, that is external radio. And once she selects that, so she is basically drawing everything by herself. What she is thinking that her laptop and the radio device is syncing, or they are connecting. And once they are connected, basically she wants to show that it's playing the music. And at some point she might want to close her laptop and open her mobile so that she can connect her mobile either to the radio or to a new device. And now she wants to play this music to her TV, not instead to her radio, and she selects the TV. So basically, given this requirement, she came up with these 8 images that she drew, and the requirement analyst or engineers basically will grab what she's doing and what are the how her interface will look like, and what are the requirements she might have or she wants. So the requirements analysts or engineers will analyze then each of those figures and extract the requirements or the interface requirements or basically functional requirements from these. So this is one way of prototyping, based on which you can not only elicit requirements but also validate your requirements, because you are looking at the interface and you say that, okay, this is possible, or this is possible to implement or test, whatever. And then there is another approach. This is also a very common approach, that is Wizard of Oz. And this Wizard of Oz is basically based on the human-computer interaction principle. So from the human-computer interaction research, they had this idea, and the idea is to see how the users interact with the system. And this is also a very common approach or popular approach, but it also involves some kind of simulation, but this is more realistic simulation than the paper-based prototyping. So I will show you basically users interact with the systems in a way that it's thinking that's interacting, but it's not. But I will show you an example how it works. And so this is an example, if you can hear the sound.
Wizard of Oz prototyping technique, and this diets, and
I think
it's a diet application. You can sign in with your Google or Facebook accounts, or if you want, you can create your own DIEX application account.
So this is the homepage of the application.
Then this page comes, and then fill in the blanks, then click on sign up.
So you are signing up. This is another interface.
Sign in page comes, just enter your username, password, then sign in, and home page welcomes you. And we have a side panel. If we drag our finger from the edge to the center, then we see.
So this is the simulation of the side panel.
We have many items here, and then
we go over them one by one. Just click on diet program. Here in diet program, we can choose our diet program, which diet we want to do, and then drag your finger to go to next item. And then here we have tracker. If you click tracker, then here tracker we have a graphic, and here we can choose, we can calculate our body.
So basically you can
here some
do the
instructions.
simulation in this way.
And then let's go to the home page, and then click on home. Then we come.
So at
here.
some point it's going back to the home page.
So we are in home again, and then whenever we open our project application, you will see the home page. Thank you.
So this is, as you see, more realistic and more user oriented. So you are concretely looking at the interface and what's coming after each action, or what is the input or output for each action. And the test engineers or requirements engineers will easily understand your requirements from this method of prototyping. That's why it's more.
This is a wizard of
Okay,
Oz.
I should go to the next. But there is also other approaches for prototyping, apart from paper-based and Wizard of Oz, and those are more technical in a sense that you need to know some technical languages, or you apply some technical frameworks. For example, Visual Fox Pro, and Dataflex is also very popular. Power Builder, even using SQL, you can do some database input-output simulations. So these are very very technical prototype. So let's say you can also use this prototype as a stopgap system. So you are developing a prototype, and you already have developed a prototype, but in the meantime you are developing the actual system. So if you failed your deadline, basically you use this prototype as your stopgap system or as a temporary solution for the users. But those are more expensive, because since you are doing automated prototype, you need to put it in the computer, you need to deploy it, or you need to run it to some machines. So it's more expensive, and also it needs more technical knowledge than the other two options. So we looked at 3 checkpoints for recurrence validation. One was the conformance to the documents or standards, and then another one was the recurrence validation, and then so we had a checklist, and also we had this prototyping method that we can also use for recurrence validation. But there are other approaches or other aspect of the recurrence validation that you cannot basically validate, and those are basically global requirements or high-level requirements, or in other words, non-functional requirements. Because, for example, you cannot test performance, efficiency, usability, or reliability using prototyping, and that's why it's very hard to promise on them. But basically you can identify them based on some other techniques that I will show after, and those are basically far from the functional requirements. So you, via the prototyping, you only implement or showcase the functional requirements, but you cannot show them these requirements, non-functional requirements. I will, I think, show it after some slides, but now I want to also talk about user manual, because we already, let's say, validated our requirements using those checklists and other analysis. And now what we want to do is we want to write a user manual based on what requirements we have. And writing user manual is another checkpoint for the requirements, because or it's another validation aspect for the requirements, because if you are writing a user manual for a requirements, and while you are writing the user manual, basically you are reading each requirement, right? And if you find that a plausible assumption or imagination is not possible for that requirement, so let's say you have a requirement and you want to imagine what could be the user interface for that requirement, and based on imagination you want to write a user manual. So if you cannot do that, that means your requirements has a problem. So that's another benefit of writing a draft user manual based on your requirements. And what are the other benefits? So basically the users who will test or who will use the prototype systems, it can be either automated prototype or the users who are simulating the Wizard of Oz prototype, they can use that user manual for testing or playing with the system. So for example, the example that I showed in the video about the diet app, if you already have a user manual based on your interfaces, user can use that user manual and use that or simulate that system. And another final benefit is that this draft user manual will be your final user documentation when you will release the system. Basically, you can modify this draft manual and then deliver it with the final system when you are deploying the system or delivering the system. So writing a draft user manual is always beneficial or another checkpoint for your recurrence validation. So this is another checkpoint for recurrence validation. So proposing the test cases, again similar to proposing a user manual or user draft. When you are proposing a test case for a requirement, if you are not able to propose a test case for that requirement, that means that requirement is incomplete or ambiguous or not consistent, or it has other problems. Because for looking at each requirement, you need to identify what you want to test or which aspect of the requirements you want to test. And defining or proposing a requirements test case for a requirements means basically you are saying that, okay, for this requirement I want to test this. And if you cannot say it, then that means you have your requirements as a problem. And that's I was talking about. So if you cannot do it, and if you can do it, that means you remove the ambiguity or incompleteness from the requirements. This test case that you are proposing for the requirements that are not yet implemented, you can also use this test case for future test planning. Basically, the test engineer or software tester is responsible for proposing these test cases. So he will look at the requirements and he will come up with some possible test cases. And if he cannot do it, that means your requirement also has problems. And test engineers or software testers are also a stakeholder of your system. So they are definitely an important part of the system as a stakeholder. So when you are defining these test cases, you don't need to think about testing resources, testing time, cost, or even test data. You simply identify the testing aspect of the requirements, what you want to test, not how you want to test or what will be the consequences or what will be the expenses for this test. You simply identify the testing aspect of the requirements. And that's another validation checkpoint for the requirement itself. So how to define the test cases? To define a test cases, you need to ask multiple questions for each requirements. Basically, you need to know where it will be used or which context this requirements will be used. And then, do you have enough information in the requirements that you can define a test case? If you don't have enough information in the requirements, that means your requirements also has problems. And then, do you need multiple test cases for one single requirement? So if you need multiple test cases for one single requirement, that means your requirements can be broken down into two or multiple requirements, and it's a compound or complex requirement. So definitely you should consider breaking it down. Then you also need to define a form for each requirement or for each test case. Basically, this is also a part of the requirements document that should be either end of all the requirements that you defined or at some as a new chapter or section. And for each requirements, basically you define a test case, and for each test case you should have this test recording form in where you include the requirements identifier. So for which requirement is being tested, or you are proposing these test cases, related requirements. So what are the requirements that are related to these requirements? So there might be some test dependency also between requirements. And then a brief description of the test cases and why this is an objective requirement test. So there is basically two kind of test, objective and subjective. But for the requirements, objective test is always important because you don't want your test cases to fail. And the description of requirements problems. So if you find any problems in the in the requirements while you are defining the test cases, you should describe them in the form, as well as if you have any possible recommendations or any solution to those problems, you can also list them. So this is the one way of defining test cases for the requirements. And this is another checkpoint basically to recurrence validation. So you define test cases for recurrence validation. I think before the break, this is the final part of the discussion. We should always, I think I also missed it during the first lecture. So for the recurrence validation, this is also another good exercise also. So whenever you have a model or a diagram or whatever, because those model or diagram reflects your requirements, and whenever you have some diagrams or models, you always try to paraphrase them, like you try to describe them using natural language in a simple way, so that non-expertise or non-technical people don't need to look at the models, and they can simply understand the model by reading at those descriptions. And if you also find problems describing your models in a natural language, that means your requirements had a problem which translated into the models, and now you are having problems describing those models. So this describing models is another way of validating your requirements itself. So for example, I will show an example from here. Basically, I will show an example using a data flow diagram, and the examples comes here. So you have a user who is ordering who is buying something from, let's say, from Amazon. So he places a order in Amazon, and his order is being processed. While his order is being processed, his billing information is sent to another company, let's say a credit card company or whatever. They are making the invoices, and they are also making the collection or taking the payments from the user's credit card. User is giving the information for the payment, his name, address, and so on, card information and other things. At the same time, user is also giving his name and address for shipping address, or for shipping. He's also providing his user address. When the collection is done or payment is done, basically users will send also a confirmation. He will be sent a statements or confirmation email, let's say, and user can also track the delivery. So based on this data flow diagram, so why this is called data flow diagram, because data is flowing from one process to another process. So while looking at this diagram, a non-technical guy or an end user who doesn't have different concepts in his mind, he might not understand everything. So to make him understand, what we do, we describe this model using this checklist. Basically, you need to identify each transformation name. So those are the transformation name: place order, invoices, collect payments. And transformation input and output sources. So what are the input and output sources for this transformation? So user, orders, and invoices. And then transformation function. So what the function is supposed to do. So basically description of each processes. Transformation output. So what are the output of each process? And finally, any exception. So for example, here is no exception, but while collecting the payment, the user might either give expired credit card or credit card that's limit has reached, so that cannot be used anymore. So there can be many exceptions for this case, for this collection payment. Or even while user is giving the shipping address, he might give improper address, so the delivery basically will have some problems. So there can be multiple exceptions. So all these exceptions will be or can be listed under this section. So the guy who doesn't know anything about data flow diagram, by simply looking at it, he will get the idea what the system is about. I think, yeah, now let's have a 10-minute break. Yeah, so let's start again. So do you have any questions from here and also online before we start the second module? Just ask them. I think nobody has questions. Okay, so before starting, if I forget, so for the next 2 lectures, bring your laptop. I mean, we will have some hands-on, and also the guys online. So have your laptop ready. Maybe it will be a little bit hard for the remote students to follow, but try to have your laptop with you, and we will do some hands-on exercises based on which you will also do your assignment. So now we will talk about recurrence management. It seems too much, but it's not. So basically, every slide has its own title. And why recurrence management is important? Maybe this figure will tell you. Again, because we have this requirements elicitation, we have requirements specification. Now we assume that our requirements are validated. So we finished our requirements validation checklist, and we have this final requirements document based on which the developers will develop the system. And basically, since the system also has his maintenance life, so changes can come in and the system will change. So the requirements also has this same effect on the system as it changes. So after this requirements document, the requirements management basically starts, and it might follow the same procedure. Like we might elicit new requirements, we might specify new requirements, as well as we might validate them again. But if nothing changes, like if you do not even introduce new requirements, the management basically, the requirements management continues. Basically, user always come up with new ideas or new requirements. So it will change or evolve anyways. So the goal is that through this process, or through this requirements management process, we will manage requirements in an efficient and cheap or maybe cost-effective way, so that we can do it with the best possible way, and we do not mess up with the new requirements or even with the existing requirements. So the goal is to define a process or a policy, in other words, using which we can manage well our requirements. And also, as I mentioned, that if the system changes, the requirements change, and if the requirements change, the system will also change. So there is a bidirectional relationship between system or the product and the requirements. So the goal is to come up with a process. In other words, we should come up with a policy that will be followed throughout the requirements life or throughout the product's life. And the principal concern or goals or objective that we want to achieve through this requirements management process or through this requirement management phase is we want to manage changes, because changes might come frequently and often. Also, we want to not only manage the changes with the requirements, we also want to understand or analyze the relationship between the requirements, because there could be dependencies, there could be not only dependencies in terms of development, there can be dependencies in terms of test and delivery and so on. And also the dependencies between the requirements document and other relevant documents. So for example, if your requirements document is being changed, your user manual will change, your test document will change, even your software documentation will change. So let's say the source code comment or comment in the source code. So there is many things to do in terms of requirements management. And the most important thing for this requirements management is basically you want to track down who proposed these requirements, why he proposed these requirements, what are the expectations from these requirements, or what is the functional aspect of these requirements, and how this requirement is related to the other information or other part of the system. So that's called traceability or requirements traceability. Basically, the goal of the requirements traceability is you want to connect as much as information on a requirement so that you can relate different stakeholders and different parts of the system. So to manage the requirements, so what is the first thing? First thing is to identify the requirements, because without identifying requirements, it will be hard or maybe impossible to read or to analyze the requirements, and for example to find or to filter certain requirements, or if you want to search certain requirements from your requirements database. So the first condition is to provide a unique identifier or a name for the requirements, but there is of course many different way and other benefits for identifying the requirements. For example, if you have a database for requirements, you can search with your requirements identifier, which can be used as a primary key. Or even if you want to version your requirements, because requirements always change, you can do the versioning in terms of identifier. And also, the most common way of naming the requirements, or maybe this most naive way, is to use numbers or versions. Like, for example, sixth requirement in the second section in chapter 4 will be chapter.section.number 6 requirements. So this is not a good approach, or not a more understandable approach. Why? Because let's say you have another requirements in the chapter 4 section 2, and you gave the number like 7, so 4.2.7. So by looking at these two numbers, it could see that those requirements are highly related, but basically those are not, although they might have similar numbers. So what's the best way to name the requirements is to use this mnemonic form. So for example, if your requirements is talking about a security, you can say SEC 001 or SEC01. If your requirements is about database, you can simply say DB01 or DB001, and then you can make a sequence of it. Or if your interface is about requirements is about interface, you can simply say INTF or INF001. So this is another way of requirements classification. If you remember, we did it in the first lecture. So basically, you are classifying requirements, and while you are classifying the requirements, you are also giving them a meaningful name. And the method is known as mnemonic form for naming or identifying the requirements. So I was talking about process or policy for requirements management. And policy, or in other words, requirements management policy, is very important and is very specific to organizations, and different organizations have different policy. But before going to the policies, I wanted to present this description of the policy itself from the Cambridge Dictionary and the Business Dictionary. So the Cambridge Dictionary defines policy as a set of ideas or a plan of what to do in particular situations that has been agreed officially by a group of people, or a business organization, or a political party. So the important factor is here is set of ideas or plan what to do. So the policies define basically what to do in a particular situation, because based on the situations, policy might change. The Business Dictionary defines a policy as a set of guidelines or rules. Basically, again, those are about what to do in a certain context or in a situation. But it can be also adopted by different organizations. So organizations have their own policy. They might have their own policy in terms of recurrence management, in terms of change management, and so on. So we will come to those after here, basically. So the goal of defining policies for recurrence management, since you should have policy in an organization or in a department or in a faculty or whatever to achieve some goals. And policies are nothing but a set of guidelines or actions that you want to perform in some certain situation. So our situation is here is the requirements management, and what or how we want to manage requirements. That's the policy. So requirements management policies define goals for requirements management, the procedures, so how it will be done, and also the standards. And again, this standard might differ across organizations. So what's the benefit of having policies? Basically, if you have a policy or well-defined sets of instructions or actions, people rely on them instead of relying on their experience, or instead of relying on their common sense. Basically, the more strict or more explicit policies you have, the more better it will be for the organizations. In that way, people will not be confused. They will not bother asking others. They will basically look at the policies that are already well defined. But what's the difference between policies and standards? Because standards also tells you what to do, and policies also tells you what to do. Basically, one of the differences is that standards tells the thing that everybody should do, not in their own way, but policies says you things that everybody should do what according to their own context or situations. In other words, policies tell you what to do or what should be done, but standards tell you how those or should those policies or defined policies should be implemented in a situation. So policies might might vary based on the situation, but standards will not vary. That's the main difference, basically. And then requirements policy or requirements management policy, what it should include? It should include multiple things, I would think 5 or 6, and all of them should be well defined. If you don't well define them, you will end up having problems managing your requirements, and your requirements might get lost or not well documented, and so on. So you first of all, you need to define a set of objectives, clear objectives, basically through the requirements management process, what you want to achieve and why you define those objectives. So rationale for each objectives. And then set of standards that you want to follow, because as I showed in the previous slides, policy tells you what to do, but standards shows you how to implement those policies. So you also need to define a specific or standards for implementing those policies. And then change management and control policies. So how you want to manage changes in the requirements, changes in the system, changes in the test cases, and so on. So for each of those scenarios, you should have a set of policies that you will follow. Requirements review and validation policies. So again, how you want to validate your requirements and how you want to review your requirements. There should be also a set of policies. And finally, policies for traceability. So what information you want to collect, what information you want to share with others. If you want to find dependencies between requirements, how you want to find those dependencies, all these things. So policies can be about traceability, policies can be about review and validation, it can be about change management, it can be even about standards you want to follow. So policy is all about rules or actions that you want to take. And also, you need to define the criteria or some maybe exceptions to those policies when you don't want to follow those policies. And in that case, managers will come into the picture, and they may decide based on the situation or the context. And basically, you are not following the policy, defined policy in that case. So why we need to define requirements traceability policies? Because if you define requirements traceability, that means you can easily find information about the requirements. Not only you can find easy the information, but you can also find relevant or related information. And for this policy for requirements traceability, it tells you what information you want to track or keep or record and or store, and how you should be storing them or use them or representing them. And then there is multiple types of dependencies. If you are talking about requirements traceability, it's between requirements. So there can be dependencies between requirements. There can be dependencies between requirements and the system design. So let's say you have a large UML diagram for the whole system or for part of a system, and you want to trace from your high-level requirements to those UML diagrams. You can do that. Which part of the diagram implements which requirement. And then also there is a dependency between requirements and components. So one UML diagram might implement multiple components in the system. So let's say one component might have 3 or 4 classes. So it's more finer grained level. So you can also do that, tracing requirements to at the component level, and also tracing requirements at the documentation level. So this documentation can be at the source code level, or even as a system level, like the whole bunch of documentation. So you can also relate those. So here is an example. So you have a list of requirements, let's say in a database or a table. So the first one is this relationship is between the requirements. Then you have the relationship between requirements and the system design, where it's bidirectional. So you can find out a particular design which corresponds to a requirement, or you can find requirements that is designed in some particular area of this design. You can also make a traceability information policy or information, or you can have traceability information between component level and the requirements. So if you have 4 components, there could be either 4 requirements or maybe more that can correspond to one-to-one or one-to-many between this component and the requirements. Or you can have requirements to documentation level traceability. Let's say this method or this class implement a particular requirements. For that, you have this kind of documentations. So you can easily say that this method or this class implement this requirement in the documentation itself. So there can be multiple types of traceability. And to have more, or to talk about more, not only between requirements and requirements, but there can be other, not only between requirements and design, but there can be other traceability information or traceability types. For example, requirements to source. So which stakeholder or which guy proposed these requirements and why. So basically this make a relationship between the requirements and the stakeholder, and then this relationship tells why that stakeholder proposed this relationship or this requirement. And this is simply requirements to requirements that was in the previous slide. This is requirements to architecture. So this architecture can be at the component level or at the design level. And this is the requirements to design traceability. So you can identify a particular part of the design that was implemented that was implementation of a particular requirements. And then there is also requirements to interface traceability. So if you are using any external libraries or any other interfaces as a part of this requirement, you can also have those information in your requirements database. So I was talking about database a lot, and I will, I think, come to this database thing after some slides. But there is some way that you can basically capture those relationships between requirements, or between requirements and sources, or between requirements and design. And one of the way of capturing those relationships is cross-reference metrics. Basically, what you do, you simply has a table, two-dimensional table, where you have all the rows in all the requirements in rows and columns. But what you have to do, basically, you have to read this table column-wise. So let's say, in general, without specifying the type of the relationship, we can say that requirement R is dependent on requirement 4, requirement 2 is dependent on requirement 3, requirement 3 is dependent on requirement R and 4, and requirement 4 is not dependent to anyone. Now, if we want to specify the relationship or the type of relationship, I listed here 3, but there can be more others, because there were many other in the previous slide. Then we can basically specialize this table into this, like requirements 1 requires requirement 4. That means if you want to implement requirement 1, you have to implement requirement 4 first. Then requirement 2 have some constraint on requirement 3. So again, requirement 3 should be implemented before requirement 2. Requirement 3 specifies requirement 1. So it seems that requirement R is part of requirement 3. So they can be possibly merged. And requirement 3 has constraint on requirement 4. So again, you have to implement requirement 4 before you implement requirement 3. And requirement 4 doesn't have any dependencies, so you can either implement separately or implement at the end, since they don't have any dependency. And this approach, or this table-based approach or column-based approach, is good for small number of requirements, because now you have 4 multiply 4, so 16 cells or 16 information that you need to store. But what if you have 200 requirements or 100 requirements? That will be too much to store or process in this way. So for that way, there is another more feasible or flexible approach, and that is called traceability list. So this is simply a table where it translates the same metrics into a table. So if you have 100 requirements, it will basically have only 100 rows. Or if you have 500 requirements, it will have only 500 rows, not like 500 multiply 500. So what it does, it has only the list of requirements in the first column, and then for each requirement, it has this dependency information. So requirements 1 depends on requirements 4, requirements 2 depends on 3, and so on. So it can be easily manageable, extensible, and the complexity is not so high for searching or traversing this table. And that's the benefit of this traceability list approach. But the only problem is that you can go easily from here to here by requirements, but you cannot go to the reverse. You cannot find the reverse relationship, because in this table, in the previous slide, you can say requirement 1 requires 4, and inversely you can say that requirements 4 is required by 1, but requirements 4 is also required by constrained by R3. So it's kind of easy from this perspective. But from here, you can say that requirement R and 4 is dependent on R3, but then you don't have any more information about R3. So to find about information on R3, you have to go to another row or another data. So that's why it's not easy way to find the inverse relationship. So this is another way of representing the traceability or dependency. So what we did is like simply used a graph. So we said here that requirement R depends on R4. So R4 must come before R1. So you have to implement R4 before R1. Then we also said R2 depends on R3. So R3 must come before R2. So that's why we have this relationship between R3 and R2. And we also said R3 depends on R1 and R4. So R1 and R4 must come before R3. So R1 and R4 came before R3. So there was this multidimensional relationship. And if you remember, we also discussed the prioritization of requirements before in the previous lecture. So this graph can also give you some sorts of prioritization. So basically you have to implement R4 at the first, and then R1, R3, and R2 because of this dependency information. So this is another way of prioritizing the requirements. So I was talking about database, and this database is also very important for managing the requirements. So in the recent development practices, the software houses, they have a database for managing the requirements. They have a database for managing the changes. They have a database for managing the bug or defects. So they have multiple databases. And requirements database or requirements management database is another crucial for the software development. And basically what it does is basically simply store the requirements. Although these days requirements are not like textual thing only. They have figures, they have diagrams, they have many other, or maybe tables or many other things. So before it was very easy or simple to store requirements in a let's say relational database or any simple databases, even in an Excel file. But now with things becoming more complex and more complex objects we have, more diagrams we have, an object-oriented database might be more feasible. Let's say a document-oriented database could be more feasible for storing or for having requirements management database. So the benefits of database is like you can easily search database, you can find automatically the relationship between requirements. So there are multiple benefits, but the most important benefit is that you can easily find this traceability information or traceability relationship between requirements and other aspect of the system, like between design or components. So before deciding or before choosing a database for requirements management, you need to ask yourself, or as a requirements engineer, you need to know these factors. So what are those factors? How are requirements expressed? So if you are expressing requirements using high-level language or text only, you don't really need a fancy database. You can simply rely on, let's say, as I mentioned, simple relational database systems. But if you want to have a more complex, if your requirements are more complex, like they have tables, they have figures, they have diagrams and models and so on, then you can go for other options, like let's say MongoDB. Then how many requirements do you typically need to manage? So if your requirement size is 10, 20, 15, you don't really need a database. So those can be managed using files or in other ways, because having database is also expensive. It's not only making the things efficient, but if you use your database for a small number of requirements, you are spending too much resource on it. So if you have 100 or maybe 200 requirements, then having database might be meaningful. And then another thing is that, are your developers or managers or engineers working at the same site and same types of computer? So if they are working at the same site, you don't really need a database or distributed database in a sense. But if they are working remotely and distributedly, then it's a good idea to have a database that is accessible over the network, over the internet. And also, do you already have a database as your resource available? So if you don't have a database, you have to think about how much it will cost to introduce a database. But if you already have a database, you can reuse it or extend it to incorporate your requirements management. And then also, of course, you need to have expertise for the database. So if you go for simple database or simple relational database, most people can handle it. But if you want to go for more advanced databases, you have to also think about the expertise if you have it. And then the change management. So we are talking about requirements management, but requirements changes. So we also need to have this policy that how we will handle those changes in the requirements. And that's why we need to define how formally or in what way those incoming changes will be handled. And one of the goal of defining these policies is that you are not basically doing favor to any particular stakeholders. So you are strictly following your policy. And if you, for example, analyze cost and benefit for each changes, then you can, using your policy, you can define and decide yourself which change you will go for without selecting blindly or favorably any stakeholders. So there are other benefits, like if you have a good policy for your change management, it's good for the audits, like you can have good, high quality reports for your changes, and that will also help the developers to reflect them easily. And also, as I mentioned, that if you have this policy, you are not doing any favor to any stakeholders, so you are strictly following that policy based on your cost benefit analysis. So how much resource you need and how much benefit it will bring to the stakeholders or the end users. And what should we have in the change management policies? So the first thing is the process itself. So stepwise clear definition or declaration that how this incoming change, when it will come from the end user, how it will be assessed, it will be taken care of, how it will be tested, and how it will be delivered back again to the customers. And also the process should discuss, as also previously I said, impact and the cost of the changes. So if it's more expensive and you don't have that much resource, it might not be feasible to make the changes. So you need to have a policy based on for those that what you will do in that case. The membership of the body that formally considers a change request. So who will be part of the team that will analyze these changes, or let's say that we analyze the cost and benefit of the changes. So that membership should also be cleared, and no one can jump in randomly and give their feedback or opinion. So there should be dedicated people. And also, as I mentioned before also, that there is a change management database that our software companies are using now. So not only they are using requirements database or requirements management database, they are also using change management database, they are using defect database, and so on, even test case database. So one good idea is to, as a part of this policy, is to have a database for change management. So a separate database for each of the changes and different information on them. As a requirement, we are talking about mostly functional requirements. And we also mentioned before that there are some requirements that cannot be met through the prototyping. And there are some requirements that you cannot promise during the validation phase or analysis phase or even negotiation phase. And those requirements are basically global system requirements. But the problem with those requirements are they are too expensive, in a sense that if you do not meet them and if you do not confirm them and the users are not happy, and it will be too much expensive to solve them or to resolve those problems that are global system requirements, because they are mostly about security, they are mostly about performance, efficiency, usability, flexibility, and so on. But if you have a list of your requirements, let's say you have 10 requirements, and you want to identify which of them are functional requirements, or which of them are critical for the end users, and you also identify which of them are very general requirements, or which of them are global requirements, in other words. And if you can distinguish between those two types, like global requirements, global system requirements, or the user requirements, then it's also easy to handle easy for you to handle them, because you don't need to really functionally implement those global system requirements. You consider them separately. You focus them from more performance objectives, not from functional objectives. So basically, you ask these 6 questions for each requirement. Like, the first question is that, is the requirements expressed in a very general way? Does the requirements express some global non-functional characteristic? Is the requirement is a general user interface requirement? Does the requirements refer to a specific functionality? Can the requirement be mapped to a part of the system model? So it can be mapped to some part of the system design. Does the requirement refer to a specific data or components of the system? But when you ask these questions, if the answer to the first 3 questions is yes, and the answer to the last 3 questions is no, that means it's a general system requirements. That means functionally it's not doing anything, but it has an overall impact on the performance of your system, in terms of security, in terms of speed, in terms of connectivity, and so on. And what you will do, so this is an iterative process, so you will do it for every requirements, and you might not be correct at the first time, but you go for each requirement and you ask each questions for each requirement, and you basically split up your sets of requirements between general system requirements and functional or user requirements. As a part of requirements management, you also need to identify volatile requirements. So what are the volatile requirements? Volatile requirements are basically the requirements that changes more, or basically this is another requirements that you can say or define them as a risky requirements. Risky not in a sense that it might fail or it might not be delivered, but the volatile requirements is basically those requirements that change naturally quite often. It can be due to the upgrade of the platform, due to the upgrade of the libraries, and so on. And it's also important to predict those volatile requirements, or maybe predict what can change in the requirements. So if you have a requirement statement that you've written, and some part of it is probably change in 5 years or 2 years, so it's also easy, or it's beneficial to identify those volatile part of the requirement. And other benefit includes, like, if you already predict the changes in the requirements or which part of the requirements could change, you can plan them accordingly in advance. Not only that, the developers can also or designers can design the system in a way that those volatile requirements are little bit loosely coupled or far away from the actual design or actual system, so that they don't have negative impact on the overall system or overall design. So this is one of the benefit or key benefits for the volatile requirements or identifying volatile requirements. And since volatile requirements change over time, so volatile requirements will also change over time. So it will be good if you update your list of requirements. And while you are updating your requirements, you should have a flag in your database, in your requirements database, with this estimated volatility. Let's say you have a column, new column, where you mention fairly stable, subject to medium term change, or likely to frequent change in short term. So if you have this flag for each requirement, one of those, that means you know which requirement should be considered with more focus, like which requirements could change in a very short while, and then implement or design them in a separate way, or maybe make them a separate design from your core design. So there are 4 types of basically volatile requirements. So requirements become volatile not only because they change, but there is of course some reasons to change. Like one of the type of the volatile requirements is they change because of obvious reason of the environment. As I said, like the operating system might upgrade, the libraries might be upgraded, the server infrastructure might get updated. So if you update your hardware or software, the requirements might need to also be evolved. So it's not your fault, it's not the problem with the requirements, but those are natural. So you need to evolve those requirements as well, and they are known as mutable requirements. So this is more natural volatility of the requirements. And then there is also emergent requirements, because when you are defining the requirements, it's not always possible to either predict or get what could be changes that will be basically visible after some time. And this is also obvious, and you cannot do anything. And whatever requirements you have, you simply change or evolve. And then there is also consequential requirements, and this could be your fault, because now you are making assumptions on the requirements that could be used, and you are defining the requirements in that way. So if your assumptions is not logical or not plausible, then these changes might occur, and it's basically be due to the error from the requirements engineer. And then there is also compatibility requirements. Also, it depends on the process or the equipment. So in other words, if your libraries or host platform is changing, your compatibility requirements might also change depending on the host platform. So basically, mutable requirements, emergent requirements, and compatibility requirements, these are natural. This is not your fault. But if you have consequential requirements that are volatile, that's the problem from the requirements engineer or other analysts who are involved in the requirements specification. Another good practice is not only record or identify your volatile requirements, but also identify or record your rejected requirements in a database, or maybe use the same database, the database you are using for requirements management. And why it's important? Because for some reason, if you are rejecting some requirements for now, eventually they might be useful or came up in the future. So basically, if you keep your rejected requirements, or if you don't trash your rejected requirements, you will save lots of money on again analyzing them, or again documenting them, or again specifying them. And you can do that also by adding another column in your database that is called status field. The previous one for the volatility, it was highly volatile, mid-term or short-term volatility. But here, if you have a a new column for rejected requirements, you can say as a comment or as a value as accepted, under consideration, or rejected. So accepted ones will be definitely be implemented. Under consideration might or might not be implemented, but rejected ones will not be implemented. But in the future, those rejected ones might become accepted ones. So we should not throw away rejected requirements or deleted requirements. We should also store them in the requirements management database. And that's another reason why requirements management database could grow larger and larger over the years, because you are not only storing the accepted or implemented requirements, but you are also storing rejected requirements. So what are the key takeaways from today's lecture? The objective of recurrence validation is obviously to find problems and inconsistencies and incompletenesses in the requirements. Then system requirements should also be validated by a group of people from diverse knowledge, skills, and background. And this not only brings new idea or diverse idea, but also different stakeholders from diverse skills get to know the perspective of other stakeholders. And that's the reason the requirements validation team should be a multidisciplinary team. And one of the checkpoints for requirements validation is implementing a prototype. So the users are playing with a mock system through input and output. And this also gives some idea on the improvement of your requirements specification. Each requirement should be identified with a unique identifier. And one good approach is using the mnemonic form, which also supports your classification approach. Using numbers does not add any meaning or semantic to your requirements specification or identification. Also, for your assignment, when you identify the requirements, you have to use this mnemonic form. There should be some policies defined for the requirements management, because if you define a specific policy and a strict policy and you follow them, you don't need to rely on other people, and you clearly know what to do. And policies not only should be defined for requirements management, but they should also be defined for changes. So the changes that are requested by the end users will be very easy and efficient to handle, else you will receive lots of change requests and you will basically get lost and fail your deadline. And finally, not only your volatile requirements should be identified because of future efficient change process, but also your rejected requirements should be recorded and identified, because in future they might be accepted and you might need to implement them. And if you store these rejected requirements in your database, you don't really need to redo the whole thing of requirements analysis, requirements specification and negotiation and all these things, including the validation. And any questions so far? I think nobody responded in Slack. And again, I want to remind you, so bring your laptop for the next lecture next week on Wednesday. So we will do some hands-on. Also on Friday we will do some hands-on, so that you don't miss it. So any questions from here? No? Then I think today we are on time, and thank you very much for your